morning. Alrighty, let's do some math. Hold on, I'm trying something new. I've got it on my screen that is sharing. At least it should in a second. How's that? There we go. Now see, my plan is... Oh, I'm smaller? See, I did that because then I make you bigger. Bigger, better for me, not better for you? Oh, okay, well, then I might have to rethink that. Anyways, let's go into where we left off. Did you try any of those questions since last time or since yesterday? Okay. Okay, let's see. Where's this one, I think? No. That was the initial one. Was it this one? Oh, there's a whole bunch of questions on this page. Okay, let's do this one. Let's go here. Okay, so it doesn't look like we've done any of these ones, I don't think. Do you have these ones done here? This is it's chapter 2. And it looks like it came after, well, this is all chapter 2. Well, let's do a couple anyways, and then we can go into the other stuff we were looking at yesterday, because there's like 2 full pages of stuff we never even started here. Okay, so this is all about the rational expressions. That's what your test is on when you go back, I take it? All of this chapter 2. Mixed operations, like with rational expressions? Yeah, okay. Because I'm like, it looked like everything you posted is coming out of the same chapter. Alright, well, let's start with this first one. What do you think we need to do to solve this? Not necessarily solve it, but simplify it, I guess. Exactly. We need to factor the denominators. Okay, so this is m. The only thing that we can factor right now is that far right stuff, because everything else is already factored. Okay, what is that stuff on the bottom right going to be factored? Good. That's a bad looking 3, but there it is. Yep. Alright, what's our next step? Yay! So I take it we didn't do any of this. Okay, good. Okay, so what are we going to multiply this first fraction by? Good. nothing on the far right. Okay, how do I multiply 2x plus 3 to an x plus 3? What do we call that? Yes, FOIL it. Okay, so FOIL this. What do we got? Good. Okay. That's a big one. Yeah, we can do that, sure. That's going to come anyways, someone as well. Looks like I'm going to need a whole piece of paper for this one question. All right, now what are we subtracting? As we distribute, though, it turns it into -2 times -1. Like you're foiling that in, you multiplied that to be minus 2x, but minus 2 times minus 1 becomes plus 2. Right, that's now all over a common denominator. So technically we have more like terms in here. Oof, my brackets are not looking very nice. Collect our like terms here now. What happens? Because I'm kind of wondering with what we have on this side, I'd have to go back to the first page. Were we actually solving for x, or are we simplifying these questions? Because that makes a difference. If we're solving, then I don't really care about the denominator. I can just start moving everything to one side and then refactoring it. Let's see, where was the start of this? Solve. It does say solve. Okay. That's what I was wondering. I'm like, do I even care about that denominator? So no, the fact that we're solving it at this point, then that changes. We don't really care about what's happening down here. We're just going to move everything to one side. Well, I mean, we did care because we needed a common denominator. But once we have that, we can ignore it and get everything to one side and refactor it. So, collect all of your like terms over to this side. What are we going to have? Yeah, that's all got to come over there too. It had exactly, yeah. On top of all the other x's. It's a bad arrow. I think so. 9 minus 2 is 7, plus 6 is 13, yeah. Okay, good. Now, can we factor this? Let's try a couple combinations. What are we going to put down our first column? Okay. What about our next column? Okay, cross multiply. We get 1 and 12. I think we're on a good path because those do add to 13. So what are our factor brackets? Good. So finally, what does x equal? Remember what makes the bracket 0? Remember that negative b over a factor. So not just negative 2, right? Our a term is what's in front of the x. B term is what's the second term in the binomial. So if I was doing this bracket, it would be negative 1 over 2. And in the first bracket, it would have been negative 6 over 1, or just negative 6. Now, it did say check your solution. So what you would have to do is then go and plug in each of those x values into the equation and see if the left side equals the right side. That's a lot of work. I don't know if I want to do that. Is there a faster way to do it? Because if I put it into this, they're going to equal 0. It has to go back into the original. I really don't want to do that. I'm going to try PhotoMath and see if it gives me that, and just hope that both of those answers are good, and if they're not, then we'll go back and put them both in and do a whole bunch more math. I don't like to check solutions. I am lazy. They are both solutions. So let's pretend we put them back into x, and that's what we get. All right, let's try one more. Let's do, Okay, so we've done that one. Let's pick a random one. How about P? Oops, that's not a screenshot. I pressed it. Okay, so this one's very similar to the last one. Looks like we've only got one part to factor. So my lazy factor is going to take over and not rewrite all this and just factor this part here. What will that end up being? Good. Except Z, but potato, yes. Ugh, my Z's are not looking very good. All right, Z's plus 2. Okay, so that takes care of this. Now we're on to common denominator. So what does the left side of the equation have to multiply up to? Okay. And the 5 is going to multiply. Good, yeah. Okay, distribute. What do we get? Okay, and since we're solving, I'm not going to care about writing the common denominator. That's all going to equal just that 5z. Since we didn't have to do anything, the denominator was already good. Okay, combine your terms. to go from there? How do you factor that? That's it. All we can do is take out the 3. Good. And what goes back into our brackets? Yes. I don't know why my keyboard is not writing 3s very well today. I have to do it very slow. Okay. So what does Z actually equal then? Yeah. Because again, if it's that negative b over a, I have a negative number. So that turns that into positive 3 over 1. And again, we could check it by throwing 3 back into this equation. Interesting enough, if I look at this, I have 3 minus 3, which is 0. I can't divide by 0 because that's going to make that undefined. That would disappear. 3 plus 2 is 5. 5 divided by 5 is 1. So the left side be 1. I'm just trying to do some quick math in my head to see what happens. 5 times 3 is 15. 3 squared, 3 minus 3 is 0. 3 plus 2 is 5. It does become 1. 1 equals 1. So it will work. We only had one answer, so to verify it, not too necessary. Okay, alright, let's go back. That takes care of this one. Oh, which one do you want to try? Pick one, your choice. Meeny, meeny, miny, mo. Okay, that one looks fun. We got 3 things to factor there. That's enthusiasm. All right, let's start with the first bit. What is that first denominator factored to? Okay. And the next one? Good. What do we call that? Difference of squares. Good. And the last part. Okay. All right, what are we going to multiply the first fraction by? Good. Wonderful. Okay, put it together. Awesome, and since we're solving it, we don't care about writing the denominator. Group all your like terms together. Oh yeah, that was an x. I put minus 1. I was like, where did that come from? You are right. fact that my lines don't really want to go good today. My 4s and my 3s not looking like 4s and 3s at all. Okay, and finally, we need to factor that to get our answer for x. Exactly. Yep. So finally, when we solve it, we say x equals good. What about because we have an x sitting on the outside of the bracket? 0 as well, yeah. So it's a -4 and also a 0. So we'd again have to check both of those by plugging them back in and seeing if either works, but since I'm going to be lazy, I'm going to try photomath real quick. And it should pick it up. And it says both are solutions, so we're good. Okay. Let's go back. I think it was this. Nope, it was the other page. So you really did that without any help. You don't need me to do those. You know what you're doing. For you, it's a matter of putting the time aside and actually going through them. Okay, so I think we'll leave this page for now because this is going to be all the same. You're going to factor things. Oh, that's a fun one. U has a cube. I think that's a cube to start it, isn't it? On, like, I can't really see because it's super small, but I think on U it's got x cubed, yeah, on the right side. Have you done synthetic division yet? You never heard of that? Then probably not. So that's going to be interesting because then you wouldn't know. Oh, but factor by grouping. You would have done factor by grouping because that's a grade 10 concept. Let's take a look at this one because that's my guess. Why is my thing so delayed in trying to give me a screenshot? Okay, so I'm only going to skip over to this side for now to factor this one. And just to give you a little refresher on factor by grouping, what you want to do is you kind of want to split the two terms down the middle. So you got two terms on the left, two terms on the right. And you factor them separately. What can I factor out of this side? Yeah, so if I take out the x squared, what goes back into the factor brackets? Good. And if I take a look at the right side, what can I factor out of this? Not just 4, but take out the -4, yeah. And then what goes back in the brackets? Good. So that's what I was hoping to happen, because factor by grouping, we're hoping to end up with identical factors, x minus 3, x minus 3, which we did. Do you remember this at all, what happens next? No? Okay, so then what happens next is these outside pieces from each of the two halves, they come together. So it's going to become x squared joining with the -4. That becomes one of them. The other one comes from the identical pairs, the x minus 3. Now, taking a look at this, other than that terrible bracket, I can take this one step further. Because what can I do with x squared minus 4? Yeah, because we have a difference of squares again. What will that turn into? Yeah. Okay, now that we've factored that one, we can now look at that common denominator piece. So, starting with the first one, what does that need? And the second one? Good. And the last one? Good. Okay. It's a long question. Okay, and that's a 2. Just doesn't look like one. All right, fix it up there. All right, so knowing that we're going to be expanding everything to collect all of our like terms so that I can then refactor it, I have two ways I can do this. I can distribute the x into the first bracket, or I could simply FOIL this and then multiply that in after. And that's probably the way I would go, because with an x plus 2, x minus 2, what does that expand to make? Not x squared minus 2, x squared, yeah. Ugh, my 2's are just not cooperating with me today. So x, I'll go real slow, squared minus 4. But that is still multiplying to that x that was out front. So that becomes now what? Good. Okay, let's go on to our second one. Since they're 1 in the numerator, that's nice. That doesn't really change anything. I can just simply FOIL this. And if I was to FOIL that next set, what are we going to end up with? Well, the 1's not going to change your answer. Multiplying anything times 1 is still the same, so I'm kind of just going to ignore it. Good, keep going, and let's FOIL the next one. There is a minus sign here, so I'm going to keep that. I'm going to FOIL the rest of it. I will have to distribute that minus sign in after. Minus, well, this was a 2, which is bad writing. Yeah. Okay. And now on the right hand side, we had everything we needed, so that's just the x minus 12. Okay, now since we were doing a subtraction, like with this plus, it didn't matter because plus isn't going to affect how you FOILed, but a minus will. That minus has to distribute into everything. So if I was to go and change it all, this is going to, and get rid of my brackets, what happens to that x? It becomes minus. I'll just erase my bracket there then. The 3 is now going to become, and then multiplying a negative to this one. Yeah. So I'll just go like this, so I'm not rewriting the whole thing. Save me a smidgen of time. Okay, collect our like terms when you're ready. Mm-hmm. Okay, I'm gonna fix that. That didn't come out very well. Cubed. Okay, the x squares cancel. Yeah, plus and minus. Okay, so you got a minus x. Let's check it. I'm going to just cancel the minus 3 with the plus 3, and then that leaves me with minus 4 plus 2 is minus 2, plus 2 is 0, and then I'm bringing that over. Yep. Looks good. Do we have a constant or no? Good, because minus 6 and minus 6 is minus 12. If we add 12 to bring it over, that's going to go away. Okay, how can we factor that? Okay, and then we end up with yep. And last but not least, we can go one step further. Got a difference of squares. Yeah. All right, what does x finally equal? Mm-hmm. Good. Now the question is, does it equal all of that? I don't know if my photomath will pick up with all that marking. I forgot to do it beforehand. Let's see if I can go back to the original question. That was you. On this page. Oh, okay. It does equal all three. Perfect. If you need to write restrictions, what is a restriction? How do you do that? Yeah, can equal that. So we can never divide by a 0. So whatever makes your denominator 0, it can't be that. So if I was to look at the original equation, even this first fraction, what's going to make this denominator equal 0? Yeah, so that would be a restriction, as x can equal 3. If I look, oh, that's a funny 3. If I look at this one, what is it that x can equal? Okay, so it can equal 2. What about over here? Now, we factored all of this out, and again, we would have had a -2, a +2, and a +3, which are the same things we got here. So these are your